Welcome back. Last time we talked about basic trig problems, so solving right triangles with sine, cosine, and tangent. Today we're going to do more complicated problems, word problems that deal with sine, cosine, and tangent. So, some tips that'll help you. Read the question carefully. The biggest mistake I see is people don't understand the question. Draw a picture. This might be the worst part of the problem for some people, and one angle must be a right angle. Label what you know and what you need to find. Determine a trig relationship, sine, cosine, or tangent. Find the missing variable and be sure to answer the question the way it's asked. Some questions require multiple steps. Many word problems have angles of elevation or depression. An angle of elevation is the angle from the ground. The way to think about it if you're looking at it is this is an angle of elevation of 0, and then this is how I measure it. It's from the ground. Angle of depression is the opposite. If I'm looking out, I have to look down. You'll see here, the angle of depression usually isn't even in the triangle, so be aware of that. Sometimes you have to keep track of what you're looking for. Here's some examples. A 20-foot ladder is leaning against the building so that the angle between the ground and the ladder is 72 degrees. How high does the ladder reach on the building? So, I'm going to draw my building. Call this B for building. This is my ground. And there's your right angle because the building and the ground make a 90-degree angle. Here's your ladder, but I know it is 20 feet long. And I also know that the angle between them is 72 degrees. It wants to know how high does the ladder reach on the building, so I'm going to solve for B here. So what relationship can I make between these two things? Well, it's opposite and hypotenuse, so it's going to be sine. Sine of 72 degrees equals B over 20. Opposite over hypotenuse. This is a pretty easy one. Just multiply the 20 over. And let's type in the calculator. And we'll just round to 3 decimal places because that's our general rule. 20 sine 72. 19.021. Make sure you're in degree mode. 19.021. Give me a unit. I gave you units, so you should give me units back. I said feet, so it's feet. It reaches 19 feet in the air. That was pretty simple. Let's try a little bit harder. A man is lying on the beach flying a kite. He holds the end of a 450-foot string and estimates the angle of elevation to be 50 degrees. Using this information, calculate the height of the kite. So, I can't draw a man laying on the beach, so I'm just going to put a point and say that's the man. And that's the kite. Well, I don't see a triangle there. Well, I measure, so here's the ground, and here's the height of the kite. Well, the height's always measured straight up from the ground, so at a 90-degree angle. Let's fill in some other information I know. I know that the angle of elevation, so from the ground up, is 50. And I know the kite string, which is the string connecting the man and the kite, is 450. So let's see what relationship I have. Again, I have the opposite and the hypotenuse. So again, it's sine. Not a hard problem, just multiply the 450 to the other side. Use your calculator to solve. $450 sine 50. 344.720. 344.720. It's a long string. It's really high up in the air. Now let's try one more example, but it's going to be a really hard one. You look out of a window from your apartment complex and you see a nearby tower. You use a laser rangefinder to determine the tower is 325 feet away from your window, so obviously you're not on the ground. You determine that the angle of elevation to the top of the tower is 39 degrees, so you think I'm looking up and it's 39. Depression to the bottom of the tower is 25 degrees. How high is the tower? So let's draw this. Let's draw what I know. So here's my apartment building, and here's me. And here's a tower over here. I use a laser rangefinder to shoot straight across and find that it's 325 feet away. The angle of elevation to the top of the tower is 39 degrees. Angle of depression to the bottom of the tower is 25 degrees. I also know that this is a right angle because I shot straight across with my rangefinder. How high is the tower? Well, I can't do this as one problem. I'm going to have to do it as two. I'm going to look at the top triangle. The top triangle looks like this. This is 39 degrees. This is 325. And this is part of the height of the tower. So let's figure out what relationship I have. I have the opposite side and I have the adjacent side. That's tangent. My angle 39 is the opposite over the adjacent. So in this case, h equals tangent of 39. Here, let's try to write that a little nicer. H equals 325. I'm going to multiply this over times the tangent of 39. H equals, let's get a calculator out to help us. 325 tangent 39. 263.180. 263.180. 263.180 feet. This does not answer the question. This is only this part of the tower. So this part is 263.180. Let's make the other triangle. The other triangle looks like this. Here's your right angle. You still know this is 325 feet. You know this is 25 degrees. This is the height I want here. I want the bottom half of the triangle. Again, it's still going to be a tangent because opposite over adjacent. So the tangent of 25 is equal to opposite over adjacent. So h equals 325 tangent 25. Let's use a calculator and solve for that. 325 tangent 25. 151.550. So h equals 151.550. 151.550. Now make sure you answer the question as it was asked. I didn't ask for either of those numbers, I asked for the height of the tower. The height of the tower is both of those numbers put together, so it's 263.180 plus 151.550. We'll be lazy and use the calculator to do it for us. $263.18 plus 151.55. And I end up with 414.73. So 414.73 feet. And in class, we will do many more difficult examples. Some of them even harder than this one. This one was pretty easy, actually, just two different parts. Some of them are going to have the same variable overlapping. It can be difficult. So make sure if you have questions about this to come see me, come ask questions, check out the notes online, and check out the additional practice problems.